the fields that we have shown tremendous aptitude and breakthroughs around the world. We were leaders in many of these, includes astronomy as a field of science. We have been very, very good in modeling the planetary motion. Though we do not have a heliocentric model, a geocentric model is good enough to actually model and locate in a pre-telescopic era the perfect positions of all these celestial objects. For this, we devised ingenious mathematics, ingenious instrumentation, ingenious observational and knowledge preservation techniques. Similarly, in medicine, I'm sure you've already gotten a glimpse of the kind of depth that we have had in medical field, be it in mathematics. So today, let me bring to you some among the breakthroughs in Indian mathematics. At the same time, the kind of very enriched pedagogy that we can bring to in our current curricular context as well. Similarly, in agricultural sciences, we were world leaders. We actually understood many of the facets such as nitrate fixation. We understood what's prana, on the earth as that is required to break down various nutrients for the plants. We understood and cultivated through deep and careful observation, and in fact through all means of valid knowledge. You would have earlier seen in the prior sessions about pramana, the important kinds of knowledge, a valid means of knowledge deduction, be it through pratyaksha, anumana, agama, upamana, and various other means. Similarly, in psychology, we were world leaders. In chemical engineering, we were world leaders. Needless to say, right? The kind of phenomenal metallurgical processes that we have had, even with goldsmiths and blacksmiths, the leading mineral miners when it comes to making gems, to making various jewelry, we were at the forefront of the world. Even now, the highest of the highest of the most prized possession is the Kohinoor diamond. So you see that we had a huge fervor for chemical engineering. Spiritual sciences was also looked at as a domain of science, wherein, just like science, you have hypotheses, you test these hypotheses, you validate them, you create a more sound ground for design of life. Similarly, in technologies, we're the world leaders in shipbuilding. Romans have written in great detail about our ships. Even 12th century, 13th century traders from Europe, even later 16th century traders from Europe have all spoken of the supremacy of our shipbuilding prowess. This is no small feat. You need to know spherical trigonometry to navigate on the ship. You need to know a great amount of valid means to build and sustain travel around the world. And these are all phenomenal aspects that we had. Simply, we mainly think that the Greenwich meridian is attributed to Greenwich, but actually much earlier, it was the Ujjaini meridian, and we clearly had latitude and longitudinal divisions of the planet, and we navigated the seas. Even before the so-called nautical mile was there, we created wonderful ways to navigate the various yojanas of the seas. Iron and steel processing, the wood steel, the Damascus swords, all came from Bharat's wood steel, and the phenomenal mining processes that we have had. Just with the calorific content and the kind of inflammable materials that you can produce with cow dung, elephant dung, even goat dung, we have created phenomenal furnaces. You imagine, an industrial era, pre the, industrial furnaces, where only coal dependency is there. You imagine an earlier era, people could do this at the back of their homes. This is called Pudam Podru in the Tamil Siddha traditions as well. In various Bengal and various other regions too, there have been very thriving schools of when it comes to mineral, metal, ore making, as well as, ore refining and creating alloys. We were all very, very good at it, thereby utilizing it through artistic value, through casting statues, for various spiritual pursuits, for various Consumption purposes as well. Casting of various metals was needed, and we were world leaders in all this, undoubtedly. In water harvesting, we were world leaders. Construction of temples and complex architecture, we were quite good at it. Textile manufacturing, town planning, name it, right? I think a glimpse of it we have also already appreciated. So I'm going to mandatorily mute all. The co-host can unmute themselves. Later, might be I will open the mic for all. The context of this knowledge system is something we should definitely appreciate. One is that we were a very value positive society, and we had a very cohesive society, and sciences were integrated into our way of life, and the sthana given to the gurus were the highest. And the kind of values, skills, and the frameworks that we have had all led to learning joyously. In that Gurukula, where under a tree, apparently, children were learning where is the lab, where is the bag, where is the, school bell ringing, right? Imagine a time. But you had to make, lessons really, really interesting. And here, schooling and educators' commitment is a few hours a day. In a Gurukula, the commitment towards education is you're full-time a teacher, literally a full-time teacher, right? So these kinds of aspects have a lot for us to understand and delve into. The intricacies of knowledge system is that one thing we must know about science and technology in Bharat is that in the West, there was science versus religion. In Bharat and in all many Eastern cultures, there was no science versus religion. In fact, science and religion thrived, co-thrived. They helped each other. They helped, they sort of pushed each other to refine further and further. One example, if we can see from Leelavati, he teaches a mathematical technique, Trairashika, and he says, Trairashike naiva tade yade daduktam vyaptam swabedair harineva vishwam. He says, like in the Indian tradition, it is thought that Hari pervades everywhere, or like the divine pervades everywhere. So through this Trairashika, this is, the rule of three in mathematics, it pervades through and throughout all forms of calculations that are out there. And he says this very, very interestingly, and he motivates this. So you can see that here they are not, whereas in the West you would see science reprimanding the religion, religion reprimanding the science, and a constant tussle. So that is why you will find it really hard, be it from the Vedic culture, from many of these aspects. You will today you will find it really hard to like split science and spirituality out, to split science and religion out, because they co-thrived very, very well. You cannot really try to distill and only take it surgically out. But today, as educators, we can learn some among these aspects of pedagogical nuances when it comes to sciences and integrate them even now. I will move further. See, for example, Aryabhata, we'll see the prevalent scientific temper, right? In 476 CE, he was born, and he wrote the Aryabhatiyam while he was just 23 years old in Kusumapura, the modern day Pataliputra. It's a huge knowledge seat. That's where he says, Chadayati Shashi Suryam, Shashinam Mahati cha Bhutchaya. This is a time, you're talking about a pre-telescopic era where he says moon covers the sun when it comes to a solar eclipse, and the great shadow of the earth is the one that is eclipsing the moon. This kind of knowledge was so prevalent, right? Many people think stories like, Rahu, the head was taken, the body was left on, all that can be also part of stories, but at the same time, we never compromised on the scientific temper. यथा चंद्रार्कसंयुक्तं तमस्तदुपलभ्यते तद्वच्छारीरसंयुक्तः शरीरीत्युपलभ्यते. Like he says that just like how when the shadow, as the darkness of the earth, the shadow of the earth is cognized only when the sun and moon are in conjunction, so too some philosophical aspect is spoken. So this knowledge was prevalent, be it in understanding why an eclipse is happening, why sudden darkness is engulfing, all this was quite prevalent. You see, this is also something that we must learn from ancient Indian sciences. This is how to set the context when it comes to education. Today, we study matrix, vectors in mathematics. Or in physics, we study also vectors, magnitude, and so on, without actually appreciating where is it needed, why is it needed, and so on. So imagine, this is how Mahaviracharya, right, a 9th century Jaina mathematician. He, in Jaina tradition, in the Buddha tradition, in the Hindu tradition, in all these traditions, you will see that religion and sciences co-thrive. You will see magic squares when you go to Jaina temples. You will see mathematical formulations and mathematical inscriptions written and inscribed in Jaina temples. In fact, when you go to Khajuraho, you will see a 4x4 magic square in the Jaina temple, which is something called the pan-diagonal magic square. Very, very interesting magic square it is. These kinds of science and religion coexisted here. That's something foundationally that we must understand as educators. This Jaina mathematician, he begins his Jaina mathematical work called the Ganita Sara Sangraha. He, is going to tell you various mathematical principles in this book. But, look at how he is starting this. लौकिके वैदिके चापि तथा सामयिकेऽपि यः व्यापारस्तत्र सर्वत्र संख्यानाम् उपयुज्यते. So in this session, we'll definitely be using quite a bit of Sanskrit. And here and there, I'll try to help you understand and appreciate it. Why? See, can you learn sciences today devoid of Latin? You can't. You will learn pi, beta, alpha, psi function, so many things, right? You can't learn it devoid of Latin. But did Latin belong to a region in the Europe? No. Latin was the language of science and knowledge in Europe. So too in Bharat, Sanskrit was the language of knowledge, language of science, in which all knowledge, be it philosophy, be it math, be it Ayurveda, be it any of the knowledge domain, was all encoded in Sanskrit. So let's not try to alienate ourselves from this cultural context where we belong to. And daringly, let us try to understand. And given any mother tongue, any vernacular language that we know in Bharat, this is quite easy to decode. Unlike when I say, beta dot alpha, or XLCBII, what is that Roman number? We will start wondering. Like that, whereas the Indian context of Sanskrit is quite appreciable. So he's saying, what is Mahaviracharya saying? He's saying that be it in Laukika or Vaidika, or in Samayika, that is worldly affairs or spiritual practices or religious matters, Vyaparas tatra sarvatra, in all kinds of vyapara, wherever there is a transaction, Sankhyanam upayujyate, we always employ enumeration. Numbers are prevalent everywhere. And then he beautifully says, Kamatantre Arthashastre. So Gandharge Natake Piva. When it comes to Kamatantra, even when it comes to Artha Shastra, when it comes to Gandharga, the musical, music, dance, and such allied fields, be it Nataka, be it Super Shastra, be it in the science of cooking. Even in cooking, right? You get the ratios wrong, that vada will turn into a stone. What do we do with it? Right? So this is quite complex. And hence, be it in Super Shastra, and be it in Vaidya, be it in when it comes to medical sciences, be it in Vastu Vidya, be it when it comes to construction, architecture, all these encompass mathematics in it. Chandolankara kavyeshu tarkavyakaranaadishu kalaguneshu sarveshu prastutam ganitam param. Be it in any domain, Ganita is very, very important and significant, he says. This, finally, after listing many domains, he goes on. I put dot, dot, dot. I've cut out few verses. Bahubhir vipralapaihkim trailokye sacharachare. What is the use in keeping on talking? Bahubhir vipralapaihkim. Trailokye sacharachare. In all these three worlds, which includes moving and unmoving objects, yatkinchit vastu tat sarvam, be it any kind of object, ganitena vina nahi. It's impossible to work. Nothing can be executed without mathematics. Isn't this such an enticing introduction? Not just this, he uses all these domains to bring out the mathematics in them in his text. His text is not bland. It doesn't say just solve for x, and it doesn't stop there. That old mathematician, now let's come to a very new mathematician, Professor Manjul Bhargavaji. He is a Princeton University professor who was also head of the new National Educational Policy Mission. And he, when he gave an interview, he's a Fields medalist. You see, Alfred Nobel didn't like mathematicians, so there is no Nobel Prize when it comes to mathematics. So the one among the highest order of awards that are available in mathematics is the Fields Medal, right? So if you look at the, when you look at him, they asked him this question: do you think why is India still a middle power in mathematics, despite its famed legacy? It has a huge legacy. There, Manjul Bhargavaji said students in India should be taught about the great ancient Indian mathematicians like Panini, Pingala, Hemachandra. Hemachandra is an excellent Jaina mathematician, Aryabhata, and Bhaskara. Their stories and works inspired me, and I think they would inspire students across India. Many of these works were written in Indian languages in beautiful poetry and contained important breakthroughs in the history of Indian mathematics. That's what he's talking about. What are some such breakthroughs? See, when we think India's contribution to math, can anyone tell, what would India's biggest contribution to math be? You can unmute yourself and tell me. What do you think is India's biggest contribution to math?
Zero.
Thank you,
Sir,
Kushal.
zero invention, sir.
Everybody thinks it's the invention of zero, which is also true. But what we must appreciate is that it's the Indian place value system. The current decimal place value system cannot be present if not for the Indian number system. The Indian number system evolved into the Arabic number system, and then it spread across Europe. Till then, you imagine doing multiplication operations with Roman numbers. Is it ever easy to do? Very, very tough, right? Very tough to do Roman number systems. Let's take an example. L, C, X, V, I. What is this number even? We have to convert it to Indian number. And then if I have to do the multiplication operation for it, right? And then if I want to do the multiplication operation and then say I, what should I do? This is a very, very complex. Later, when you have the time, please go through the internet and understand how to do multiplication in the Roman number system. Earlier, the Romans used to physically have people called the calculators. They had to go everywhere with the Roman traders. Calculator is not just an instrument. Today, it's an instrument. Like, ATM was earlier a teller in a bank, right? Now that ATM has become, that has become a mission. So too the calculator. Earlier, calculator was a job position. So people used to take up the calculator job. They will go in papyrus. They used to work out. Very elaborately, they used to work out using the number systems. Whereas the Roman traders, when they interact with Indian traders, back of the hand calculation, mental calculation was a very, very important aspect when it comes to Indian mathematics. You see, the world would suffer if not for the Indian mathematics. And it starts from the decimal place value system. And very wrongly made be known to all of you today, from today on, that it is the decimal place value system that is India's contribution to mathematics, not just the zero. If not for it, you can't do many fast, quick calculations. Okay. Similarly, the Bhuja Koti Karna Nyaya. In fact, many of these fast calculations we are not even, learning, be it in Vedic maths and many of this. Sadly, it's not still mainstream. They are always worried how to take this. But, max is max. From wherever, if it is in the Vedas or not, you'll have to take it and then utilize some among these pedagogical facets. So, similarly, the Pythagorean theorem, the Bhuja Koti Karna Nyaya. It's attributed to Pythagoras. At least a few hundred years before Pythagorean school came up with it, it was already well established as a theorem and presented here. Even today, when you do constructions, if you see, I'm sure many of you would have constructed your houses. There, when you see the masons, how will they know this corner? When they build a corner like this, how will they know if it is perfect 90 degrees? They will use a Pythagorean triplet. They will put a stick here, they will put a stick here, and another stick in the corner. If you can see in my, in my background, you will see a corner. In this corner, they will put a stick. They will put a stick another place here and another place here. They will connect this diagonally and then see if it forms its 3, 4, then the diagonal will be 5. In such a case, this will be a right angle triangle. So even today, Masons use this technique. Okay, even today. And so this is a very, very important innovation that we have had in the Indian tradition. And it helps us in many, many places in constructing roofs, in constructing perpendicular roads, in city planning. In many of these, the Bhujakoti Karna Nyaya plays a very important role. Very, very importantly, plays a huge role in shipbuilding and navigation. So in navigation, there are very interesting problems. In today, I'm sure the time will permit, we will look into some problems in the intersection of astronomy and navigation. Okay, I'm giving you a broader context. In some time, we are going to get into techniques, some nice techniques in Indian sciences that we can actually, as educators, learn and teach many children. Combinatorial rules. This is also something we are really, really good in, combinations and combinatorics. And so too in Indian calendrical calculations, we were good. We were good in finding the analytical expression of the sine function. Trigonometry, we were world leaders. I'll show you how, the trigonometrical table is. While we all studied, I'm sure we all went through something called the Clark's table, right? It's a small, thin book in which we can get the sine values, cos values, z value. If you are a statistics learner, you could, get a few things from the Clark's book. Like that, the first person to write such tables is, in fact, Aryabhatta. We think Aryabhatta invented zero. Zero was already there in the Indian tradition. What all Aryabhatta invented, we sadly don't know. We will get a glimpse of it today. Similarly, the analytical expression for the sine function. Sine function can be written as a recursive function. That even today, it will quite benefit computer science students to learn many of these facets. Solutions to indeterminate equations, infinite series, like that, they made many breakthroughs. Why should we value this Indian knowledge systems in our pedagogy? See, exposure to diverse pedagogical aspects. We being educators, we must know how all can we approach, teaching a particular concept. Today, I will delve a bit into mathematical concepts, okay, math and astronomy if time permits. And health sciences, you have already had a glimpse of and big history too. Then exploring possible models of integrating this also we will see. Okay, a glimpse into IKS pathway for enabling joyful teaching and joyful learning. We will try to appreciate today. See, the most important facet of Indian knowledge system is that all this they have achieved it as an oral tradition. See, with oral tradition, you can teach some shlokas, but how can you teach math? Which means there is no school bag in this tradition. There is no notebook to sit and do math problems. Yet, they created wonderful ways to teach math and build math skills for all in the nation. And they use not just in math, in all traditions, all knowledge traditions were oral traditions. And these oral traditions involves, oral medium of learning. Right? Auditory cortex is at the very center of the brain. The visual cortex is at least in the front, and it can get excited by looking at a presentation, by looking at various things. But the auditory cortex is the center of the brain, a sandwich between the Broca's and the Wernicke's area. Very important. Today, NIMHANS, the National Institute for Mental Health and Neurosciences in Bengaluru, one among the foremost institute in Asia when it comes to neuroscience. They are studying how even brain stroke can be reversed. When you have speech problems and so on, you can reverse it by slowly chanting, listening more, and then, singing more. All this they are trying to figure out. Similarly, we had a written script that was precise and alpha syllabic in nature. Our, though writing was not our daily pursuit, it was understanding. But once when it comes to writing, when you write it finally in your palm scripts, in fact, in the Thinnai schools of the earlier traditions, see, children, for example, you belong to, let us say, a community that is working a lot in water harvesting. Let's say you can build tanks, you can build wells, you can build huge community, lakes or tanks. Such cases, you need to know volumetric analysis, right? You're working with volume. So you need to know cubes and cube roots very, very well in order to be good at it. So while they are graduating, they will write cubes. So everything 1 by 8th cube, 1 by 24th cube, they will write full tables of cubes so that that's easy for them to look up to. And they will find some shortcuts in their fingers to quickly calculate cubes and cube roots. If today, at least for squares, we'll see how to do them. Elaborate design of prosody, that is, everything was written in metrical meters. You can just go on singing this entire knowledge system and keep it stored in your brain. Look at our children. If we want them to by heart one paragraph, it is very, very tough for them. In the same children who go on the bus, listen to a cinema song for 1 or 2 times, they're able to chant it, they're able to sing it. Then memory power is not the problem. The problem is the non-alpha syllabic language in which right now, sadly, we are speaking with each other is a language which is not a refined language, right? This English language is a funny language. It is not at all, scientifically good enough to design various things. Similarly, and we created ingenious number system that demands the mind to process complex cognitive load while achieving perfect training. How it will happen is, see, the 72 Melakarta ragas, the 72 ragas are all encoded in what is called the Kattapayadi number system. Just knowing the first two syllables of the Kattapayadi number system, you'll be able to decode the entire raga. So it works like that. It's very, very, very powerful system of encoding details. Today we study it as information coding theory, ICT, in computer science, but that was prevalent in many domains, be it in music, be it in arts, be it in even rhythms and so on. So today, some possible areas for educators are Sanskritam. It gives you great neurocognitive benefits. You have already seen a bit about the Sanskrit effect in the set of lectures that we have had. And Ganitam, Ayurveda, Nakshatra Vidya, Paristhiti Vigyan, ecological sciences, Itihasa and Niti, Yoga, bringing all these as educators into our curriculum has a multi-pronged, multidisciplinary benefit for our children. And again, it definitely develops multiple intelligences. While reading math, you learn some music. While learning music, you learn math. Today, as educators, we are struggling to integrate, coming up with new ways to integrate art and sciences. It's become a huge, challenge for us, which seamlessly ancient Indian educators have done. I'm going to present 1 or 2 examples from Ganita, then some astronomy, then any other allied field of sciences we'll see. Another Fields medalist, David Mumford, he wrote in this book called Mathematics in India, the review of this book, Kim Klofker's book it is. He said, did you know that Vedic priests were using the so-called Pythagorean theorem to construct their fire altars in 800 BCE? And that the differential equation for the sine function, in 800 BC, he is talking about Bodhayana. So this International Mathematical Union now is, has also added the another name for Pythagorean theorem as Bodhayana theorem. So this belongs to Bodhayana way before, Pythagoras. Then it's not even Pythagoras who invented. Later in his Pythagorean school, someone invented it. Then the differential equation for the sine function. Okay. We are talking about a time when English was not even born. There we are talking about calculus. Okay, the differential equation of the sine function, not in the continuous form, but in the finite difference form, was described by Indian mathematician astronomers in the 5th century CE. This he's talking about Aryabhata. He's talking about Aryabhata in the 5th century. And that the Gregory's infinite series was proven using the power series for arc tangent with ingenious summation methods used to accurately compute pi in the southwest India. This is the Kerala school of mathematics he's talking about. He's in fact talking about someone called Madhava in the Kerala school of mathematics in 1350 and 1400s. He built, he gave these infinite series for pi. So even now, when you use phone to calculate sine values, all it uses this infinite series and truncating that infinite series for sine values and so on. See, this very word, have all of you heard this word sine, cos, tan? Sadly, we have all heard, right? We have all studied math in our schools. What is this sine? What is this cos? What is this tan? Is a big question for us. In fact, it was Al-Khwarizmi. The very word algorithm comes from the Middle Eastern mathematician Al-Khwarizmi. Al-Khwarizmi was a slave to a master, but a very genius person. When his master came to Bharat, Benares and a few other places, he came here to Bharat, I think for about, if I'm not wrong, for about 32 years as per his biography. For let's say for an extended period of time, he was there in Bharat. And he wrote a text called Hijab al-Hind, in which he brings out all the mathematical concepts of Bharat. And that is how he was instrumental in spreading it to all the Middle Eastern kingdoms of those times. Al-Khwarizmi. That's why remembering him, even today, we have the word algorithm coming from Al-Khwarizmi, because he came here, studied various things, he annotated, he made excellent notes. See, for today, who becomes more famous? Does the teacher become famous, or the student who writes good notes in the classroom becomes famous? Right? Before the exam, people come searching for the person who wrote good notes in the classroom, right? To Xerox and study. Like that, Hijab al-Hind became a very popular text. He did a fantastic job. Similarly, much later, Faizi, the court mathematician of Akbar asked him to fully translate Leelavati into Persian language. So this is how a lot of spreading of knowledge happened, in between these times across these scholars of the different eras. Now, you see, Ja or Jiva became Al-Jab. Jab means also, pocket, crevice, and then so on. And that got translated as sinus. And hence today we have the sine function. Kotija became cosine. All these are well documented by mathematical historians. Somehow it's still not there in our education. And only, teachers like you can bring out the true story behind many of these facets. See, this ja, see, when it comes to trigonometry, Indians started from a circle. They took a circle, okay? This is called a ja, okay? This looks like a bow, right? And it's string. So this is called chapa. Chapa means bow, and it's string. And this looks like an arrow, right? If you complete it, this looks like a string, right? If I complete this diagram, this looks like a bow, and this looks like the arrow that now I can string the bow, pull it like this, and shoot the arrow, right? So this I can do, right? Based on that, they named all these terminologies. So this got called as chapa or the arc. This is called arc. And this is the sine value for any degree. If it is a unit circle, if the radius is equal to 1, then it's a unit circle. But this will work in any, but it is written as r sine theta in max. It's written as r sine. So this aspects they had in the Indian tradition. So this was called ja. This is called kotija. This is called the karana. This hypotenuse is called the karana. And they found out these values, for different heights like this. They found out these values and then they tabulated them. This is Aryabhatta. He gave a table for all these values. This is how for, and in fact, he found what is called today in computer science, we have something called recursive function. This recursive function first Aryabhatta wrote to find the sign values itself. Please give me one moment. So, as I told you, he took this arc and he found various arc lengths, and then he created a beautiful table like this. And this entire thing is coded in what is called as the Arya-Button number system. And this is all sign values, sign difference functions. This, what is the first height? How is the next sign value higher than this? How is the next value higher than this? And then so on, he gives for different theta. Maki baki baki dhaki na kinya ki aki hash jas kaki kish gash gaki ki gwa dhaki ki grahakya dhaki ki cha skash jangva klapta phachakala dhajyaha gives like this. That is very easy for us to remember. And see, for ma, yeah, if you go from ka kha ga ga ga, when you count all the letters, ma will be the 25th letter and kha will be the second letter. But a stands for 10 power 0 and e stands for 10 power 2. So 2 into 10 power 2 plus 25 into 10 power 0 will be 225. Like that, he encodes. Very, very brilliant things he does. And as we already spoke enough times, the key aspect about Indian science, presenting science as, in poetry, any, scientific literature, very huge corpus of it, be it in any domain, was written not only in Sanskrit but in poetry. Why? The rhythmic poetry helps us very well remember, right? And, pursue a problem. Today, when it comes to 10th standard mathematics and so on, they say solve for x, and then they present a problem. X square plus 4x plus 10 equal to 0. They present such a problem. But look at how in Leelavati, in Bhaskaracharya, in the 12th century CE, this is important to know. See, Bhaskaracharya is another very, very important mathematician. 12th century, he was there. He belonged to Maharashtra. Chaul is gone. Bhaskaracharya, he gave the Leelavati. This is from Leelavati. So this Leelavati was the most used, this Leelavati was the most used mathematical text when it comes to Indian mathematics to teach. Today we say we want to buy that guide, buy this book, right? So this book was the most sold mathematics book, so to speak. Why I'm saying sold is because manuscript, so many copies of this manuscript was there everywhere. Look at this very interesting problem that Bhaskaracharya gives in Leelavat. Okay. And now I want you to all interact. I'll ask you a few questions. You try to answer. I will finish, explaining this, and then we will, understand this better. Okay. And we'll discuss about this. He's saying, Partha Karnavadhaya Marganaganam Kruddho Rene Sandadhe Tasyardhena Nivarya Tacharaganam Mulaishaturbhirhayan Shalyam Shadvihi Atheshu Bhistribhirapi Chatram Dhvajam Karmukam Chiche Dasya Shirasharena Kadite Yanarjuna Sandadhe. He says. So we all know Partha is Arjuna, right? and he is going to do the Karna Vada. And he is employing in this battlefield, in the Krudhorane, in the Ghori battlefield, he is continuously sending arrows. Okay, continuously sending arrows. And let us say he is sending X number of arrows. Let us say not X, let us say he's okay. We'll take A number of arrows, A for arrows. Okay. Let's say he's employing A number of arrows. Half of this, tasyardhena nivarya, half of it was used to tackle through defense the other arrows that are coming. So nivarya means defense. Half of the arrows that Arjuna employed were to defend the other arrows that were coming at him. Okay. Sasyardhena nivarya tacharaganam. Then Mula Ishtaturbhirhayan. So he's saying, if you take A, now take root A and multiply that by 4. He's saying if you take root A and multiply that by 4, these were used for tackling the horses of Karna, to immobilizing the horses of the chariot of Karna. Then Shalyam Shadbihi. Would any of you know who is Shalya? 6 to immobilize Shalya. Any thoughts on who might be Shalya?
The
Sir, chariot of
Rathasarathi.
Karna?
He is the Rathasarathi of Karna.
Yes, ji.
Charioteer of Karna, sir.
But who is correct? He is the Sarathi. Here Partha Sarathi is Krishna. Here Shalya is the Karna Sarathi. But who is really Shalya? How is he related to everyone?
Pandavas.
How is he related to Pandavas ji? You know Nakula Sahadeva, his maternal uncle is Shalya. In fact, he comes with one Akshogini of warriors. While he was just coming with one Akshogini of warriors, he travels from a long distance and comes. Again, Akshogini
He is
means
Madri's brother.
their mother, their Madri is their mother, so maternal uncle.
Yes.
His own.
Yeah, he's my maternal uncle.
Shalya comes with one Akshogini of warriors. Akshogini is an arrangement that comes in certain geometric progression. GP, we study AP and GP, arithmetic and progression and GP in our schools. So Akshogini is arranged in a geometric progression. So this Akshogini of warriors he comes with. But now what happens, as soon as Shalya comes in, all, his great feast is given. Today when we go to some hotels, then they'll give a welcome drink. They'll give complimentary that, complimentary this, we'll give 5-star ratings for them. So like that, what happens? So Shalya comes and then he's immediately given a feast. He's very, very tired, thinking who else can it be other than his own sister's sons? Who else can it be? Thinking that he is commanding his army. Hey, to those who have given us this food, we should give our lives to. And immediately who walks in? Duryodhana walks in saying, Namaste, this food was brought to you by. Like that, he says that I am the sponsorer for this, feast. And thereby now Shalya has to obey those words. So to immobilize Shalya, 6 arrows are used. So if A arrows were employed, A by 2 is used for defense. 4 root A is used to tackle the horses of Karna. And 6 is used to tackle Shalya, the charioteer of Karna. Now see, a math class is going to Mahabharata story, some Yuddha Niyati and all this, it's coming back now. Atheshu bhisdribhirapi chatram dhvajam karmukam. Then one each is used for the chatram is the umbrella. Dhvajam is the flag. Karmukam is the bow of Karna. Gandiva is the bow of Arjuna. Karmukam is the bow of Karna. And so 3 are employed to destroy these 3 facets. Okay. Then finally, to the head, one is aimed. Chiche dasya shiraha sharena kadite yanarjuna sandadhe. Now tell me, how many arrows are employed? Is what Bhaskaracharya is asking. See, Bhaskaracharya keeps talking to a girl called Leelavati in his text. He keeps addressing children. So this court poet of Akbar, Faizi, thinks that Leelavati is the daughter of Bhaskaracharya. And he tells that this was taught to her. It could be many other children also, but certainly a character called Leelavati is addressing in this text called Leelavati. So he's saying like this, you see, a by 2 plus 4 root a plus 6 for the horses plus 3 for the umbrella, flag and bow, and finally 1 is aimed at the head of Arjuna, and all these adds up to a, which is the originally total number of arrows employed. So now you have to solve this equation. Okay, now you have to solve this equation. Now let us substitute a as x square, because then root x will become x, correct? So let's say this becomes x square, right, by 2. That is this equation here. X square by 2 plus 4x plus 6 plus 3 plus 1 equal to x square. If you change that, it will become this kind of equation. Now if you solve, today when you go ask the 10th standard students, 9th standard students, they will say how to solve quadratic equation, minus b plus or minus root of b square minus 4 is all that they will tell us, right? So like that, now they want us to find total arrows employed. If you solve for x, you will get here minus 2 or plus 10. Minus 2 cannot be employed. So x will be equal to 10 in this equation. And if x is 10, x square will be 100. So totally 100 arrows will be employed. Like that, very interestingly, storytelling. See, many of the pedagogical techniques that we are learning today, you see how seamlessly they have integrated. There is a song, there is a story, there is a quadratic equation, and all this to a very young child. Today, even our 10th standard students are struggling to clearly understand many of these concepts. You have already heard about the Sanskrit effect in the earlier lecture I saw. Similarly, this alpha syllabic language, right? It triggers different regions of the brain, because as you see the word, see, it's very, very tough, right? I don't know if Matushi is, Antalakshmi ji already shared this, right? Ghoti. How to pronounce this? Yes, Professor Kishoji is saying Ghoti, right? So if it is Ghoti, right? There is this George Bernard Shaw. I'm sure many of you should have heard of him. Fantastic, witty English writer and playwright as well. He said this is pronounced as fish. Ghoti can also be pronounced as fish. How in rough, tough, GH if sound, right? And in woman is singular, plural is women. And so O gets the sound of E in women. So phi has come. Addition, subtraction, multiplication, division, all that is TI is ish sound, right? After telling this, George Bernard Shaw very famously said, English is a funny language, but showing this example. Why? Because what you read is not what you speak. This creates this dissonance in the cognitive capabilities of a child. The neuronal firings don't happen in a very balanced way. Whereas when it's an alpha syllabic language, look at all our vernacular languages. Look at Telugu, look at all the vernacular languages in Bharat, look at Sanskrit, all these, they are mostly alpha syllabic in nature. How you write is how you pronounce it, correct? There is hardly any difference between how you write and how you pronounce. So this is called an alpha syllabic language. That in itself, learning why today we say in the NEP Bharatiya Bhashas, because it phenomenally triggers brain development in children. I was earlier talking about, right? The Bodhana Silpa Sutra has given this. All these are also given in the Sutra model. Dhirgha Chaturashrasya Akshnyarajjahu Pashvamani Triangmani Jayat Pratak Bhute Kurutaha Tadubhayam Karoti. So, which means they had to find the square values, right? Quickly. They had to build structures like this earlier, which led them to a quest on pi. This is called Garhapatya. This is called Dakshaniya. This is called Ahavaniya. And the idea of building these three fire altars was that it should all have equal surface areas. So for that, you should know root 2 value, you should know pi value, all that you should approximate. Indians already knew that pi and root 2 were all numbers which are not representable as fractions. Today the West calls them irrational numbers. Why? Because Hipparchus came up with this. He was tied in a stone and thrown into the ocean because he was irrational to come up with such thing called the irrational numbers. So we built complex Agni Kundas like this, which all helped us, approximate various values, okay, such as, the root 2 values and so on. Now, today, how can we use the Baudhana Sulpa Sutra in its sutra form? How do we teach that to children? Right? There are some interesting pedagogical things we can draw. See, let's say we want to today, we don't teach a lot of geometry. We teach only mathematical computations and arithmetics. But if you want to geometrically add two squares, okay, take two cardboard size squares, and if you want to add them geometrically, okay, let's say this square is of side length A, this square is of side length B. Okay, for convenience, let's call this the square of length 5 units, this of 3 units. You first place both the corners aligning like this, okay. Then you draw this line from this place to this place. Then if you connect this place to this point, you will get a diagonal, right? And this diagonal, using this diagonal, if you construct a square, diagonal as its side, this square will be equal to the sum of these two squares. Okay. Very nice activity. You will see this will perfectly match. Similarly, how would I subtract two squares? Again, take two squares and align them, two unequal squares, and align them in one corner like this. Now, again, draw this line, which we did last time. Last time we connected this as a straight line. Now draw an arc. This as the center, this as the length. Update, draw an arc. It will come meet at some point here. Construct a square. And now this will be a square minus b square. How ingenious is this? Think about it. We are not teaching many of these pedagogical techniques right now. In fact, all of arithmetics originated from geometry. We had to construct various things. Other fields pushed mathematics in Bharat. Various other fields ensured that math was given a lot of weightage and very nice pedagogical techniques. You see, and all algebraic identities, right? Different years, different mathematicians gave different beautiful proofs, right? For example, a plus b the whole square. So split it like this, right? Into segment A, segment B, A and B. So now you have component areas, A square, B square, AB, AB, 2AB put together, right? So, we see this today in some places and we don't know who found it. It is Indian mathematician Jeshta Deva who has demonstrated all this. Similarly, A minus B the whole square. He's saying take 4 strips of dimension A times B. You get 4AB, right? AB, 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 AB as the areas, right? You arrange them like this neatly. In the center, there will be a cavity that will form a square whose length will be A minus B. This whole length will be A plus B. This length will be A minus B. Why? This entire length is A in which B is going away. So you're left with A. So this is saying, right? This entire thing is A in which you cut off B length, right? So what is left is A minus B. All 4 sides A minus B will be left here. So this area in the center, he is calling it as the A minus B the whole square area. So A minus B the whole square is nothing but from A plus B the whole square, remove 4 ABs and you will get A minus B the whole square. And hence you will get the formula for it. Similarly, A square minus B square, you remove a small square from it. You are left with this kind of a shape. You cut this piece, you rotate and transform and rearrange it like this. So now you get A plus B into A minus B, just as Deva says. So, but where is all this used? He will teach you where to use it. I'll tell you how to use it. Okay. Similarly, A plus B plus C the whole square. You see how very, very nicely we can learn formula. Take a big square. For example, let me help you with the example. Then you will get, let us say this entire length was 7 units. Okay. Was 7 units. So you make one square with 1, split this into 1 plus 2 plus 4. Okay. Can we split 7 as 4, 2 and 1? We can do that. Similarly, a plus b plus c, you can split any number, you can split it into a plus b plus c. Right? And so what does he say? You market these areas. Once you demark these areas, what is happening? This is becoming, this area will become a square, this area will be b square, this area is c square. Then adjacent, I will write it here, maybe it's easier. See, this is a square, this is b square, and this is c square, right? And this, look at this area, this is a length, this is b length, and this is c length. So what is this area then? This area is a into b. This area is also a into b. So you get 2ab, a square plus 2ab. Then what is this area? AC, AC. So you get a square plus 2ab plus 2ac. Then you get b square, then bc here, plus 2bc. B square plus 2bc. Then all you're left with is only c square. So c square is there. Today, without explaining like this, we are just teaching this formula for children, which is quite unfortunate right now. So, these all we can draw from ancient Indian mathematicians. Where is this used? See, we will see where it is used. Okay. To find the square of any number ending in 5, what can we do? So, first we all know 5 square is 25. So, we write that now down. Then what is the next number in front of 5? 4. 4 and its next number is 5. 4 into 5 is 20. So the answer becomes 20, 25. Okay. So another example, 75 square. What to do? 5 square, 25. If we take the other number 7, its next number is 8. 7 8s are
35.
7 8s are 56. 5625 is 75 square.
Razor.
Similarly, let us take 145 square. 5 square is 25. 5 square is 25. Then the rest number we are left with is 14. 14 into its next number is 15, right? 14 into next number is 15. So 14 into 15 will become 210, right? So 21025. That is 145 square. So how is this working now? Why is this working? What I'm saying, write 5 square, take the remaining number, multiply it by the next number to it, right? Why is this working? For 85 square, 5 square, 8 and its next number is 9. 8 into 9 will become 72. So 7225. Why is it working? Similarly for 145 square, right? We just saw. Why is this working? It's a rearrangement of this identity. A square minus b square equal to a plus b into a minus b, we know. So this minus b square, if you take it to that side, it will become plus b square, right? So then a square is equal to a plus b into a minus b plus b square. This is very, very useful, right? See, for example, when I want to find 35 square, I can do 35 plus 5, 35 minus 5 plus 5 square. That's why we say 30 into 40 will actually become 1200, leaving the last two units as 0, 0, right? So that plus 25 if we add, so you can just forget these two and then do 4 into 3 alone here. Similarly, for 14 into 14, for many of this, it will work well, right? It's very easy. So if I want to do 14 square, You want to do 14 square. Now you must know that in this base, only one digit is there, right? Only 110 is there. So, what will 4 square be? 16. So you write 6 and plus 1 as carry over. And look at 14. How far away from 10 it is? Plus 4. So add that plus 4 to that 14. It will become 1, 8. Now if you sum total, it will be 6, 9, 1. So like this is used for various techniques like this. This is all Indian mathematicians were good at. But what if I want to do a general number square? Okay. Samadvighata kritiruchadetha sapyontyvargo dvignanti nighnaha. Bhaskaracharya. Leelavati. Beautiful poem, Leelavati. There's all mathematical concepts in it. Okay. First he's saying kriti. What is a kriti or a varga? Varga or a kriti is called a square. He's saying kriti means product of two equal quantities. Samadvighataha. Kritihi uchyate. This said so. Atha. How do you do? He's saying one method now. Stapyon tyavargo dvigunanti nighnaha swasvo parishta jatatha parenkaha tyaktvan tyamutsarya punascharajam. He's saying, okay. To understand that, we will do some, we'll first understand that it is using this technique. Okay. We just saw, right? When it comes to a plus b plus c plus d plus e plus f, whatever it is, you have to first write. If you have this, for example, you first write a square, then 2 times a into all other components, b, c, d. So 2ab, 2ac, 2ad. Then you take b square. After b square, you write what is left after it, 2bc, 2bd. Then c square, then 2cd. C square and 2cd. Then all you will be left with is only d square. So you write this d square. So like this works. So he tells this. And then following that, he tells us how to utilize it. For example, 57 square. We want to find 57 square, let us say. Okay. 57 square. First write 5 square here. Then you write 7 square here. Now in between them, right? 5 into 7 times 2. Okay. 5 into 7 times 2. See, 57 square. You're going to calculate. Okay. First you write 5 square here. This will be 25. Then you write 7 square here, which will be 49. Then do 5 into 7 and then double it. 2ab basically. 5 into 7 and double it. 5 sevens are 35. Doubling that, you will get 70. So you shift one place here and then write these digits. So now if you add, you will get 9, 4, and then here 3, 2. So that will be your sum total. So if you add all this, you'll get 3249. Very easy, even for multiple digits, bigger digits, the same principle can be used. 364. Write 3 square, write 6 square, write 4 square. Now, next what you should do, multiply 3 into 6 and double it. Multiply 3 into 6 and double it. So if you do that, 3 into 6 is 18. Double that is 36. Then what should be the next step? Multiply 6 into 4. You slide it one place and write it here. Then next step, 6 into 4. 6 into 4 is 24. 24 times 2 will be 48. You slide that one place here and then write 48 here. Now what you are left? You are left now with 3 into 4. 3 into 4 times 2. Right? So 3 into 4 is 12. 12 times 2 is 24. You slide 2 places. Now you slide 2 places here and then you are right. Now if you sum total everything, you will get 6, 1 plus 8, 9, 6, 4, 4, 14, carry over 1, 1, 3, 6, 10, 10 plus 2, 12, carry over 1, then 13, carry over 1, 1, 3, 2, 4, 9, 6. This will be your square. How is this working? The same principle, right? The same principle. What is this made of? 300 plus 60. This is the power of the decimal place value system. Plus 60 plus 4, right? And we are trying to do its whole square. So you've got a square here, which becomes 0, 9. If you write here, rest are all 0. That is the meaning, right? Rest are all 0. If you slide one place and write, it means all are 0. So that is what you have written here. Similarly, 60 square is what you have written here, 3600. Then 4 square is what you have written here. Then 2AB, you write here. Why? 300 into 60 will move 3 places because 0, 10 into 100, 3 places, 1000 places it will move it. Then 60 into 4 will move 1 place, only 1 place. 60 into 4 will have 1 0 and rest will be 20 times 2, 48. Then 300 into 4 will move 2 places. We'll move these 2 places and then we have to write it here. Like that they devised. What Indian mathematicians taught as elementary mathematics is 8 arithmetic operations, not just 4. Why? Lifelong you need these arithmetic operations. If not, it is quite tough. Okay. Because you had to know mentally to do many of this. If you practice many of this, you can easily do it mentally. This is what they had to do. Sankalanam, Vyavakalanam, Gunanam, Chedanam, Vargam, Vargamulam, Ghanam, Ghanamulam. They had to do all this mentally. In fact, it's like this. Now, if we go a bit into astronomy, astronomy and math went hand in hand. And that also, is very, very interesting field of Indian science. Metallurgy, astronomy, many of these are very, very interesting fields of Indian science. So when you look at astronomy, let us look at some examples from astronomy. Okay, very nice examples we'll see. Okay, so this first we'll begin with a question to all. Where does the sun rise and set? East and west, we will say in general, correct? Where does the moon rise and set? Any idea? Where does the moon rise and set?
Same direction, sir.
Where does the moon rise and set? Sorry, Ji?
Same direction, sir. East and west.
East and west. Oh, okay. Any other alternative answers?
It's just there in the sky, sir.
Moon is just there in the sky, right? Where is it rising in? We have seen sunrise. We have sunrisers team there, Hyderabad. Sunrisers. There is no moonrisers team. Nobody said moonrise. They kept a coffee name also sunrise. Nobody has kept moonrise name. Correct. Moon never rises. Any other answer? Does the moon rise anywhere else inside? Anywhere else? Anybody feels other direction, opposite direction, it will rise inside. Okay. Okay. Let us leave moon.
It just rotates. It doesn't rise or set. It just rotates.
It's just there.
So there is no point of rising.
How about the stars? Do they rise and set? Do the stars rise and set? Yes, ma'am. You said
No, sir. No.
Yeah. Star, does it rise and set? No. Right. I'm sure many of you are or already know this principle, right? Why does the sun rise and set? It's because the earth is spinning, correct? The earth is spinning, and that's why the sun is rising and setting. I'm sure all of you know this already. And I'm sure all of you are now sitting on a comfortable rotating spinning chair. Correct. If you were sitting on the spinning chair and if you were spinning, okay, if you were spinning, all the objects around you in your vision, do they spin? Moving objects, unmoving objects. Will all of them spin?
No.
Why not, ma'am? See, if I'm sitting on a spinning object and I keep spinning, if I'm sitting on a spinning chair and it keeps spinning, in my eyes I will see going the other way.
Yes, sir.
So if I spin one way, in my view, everything will go the other way. In my view, objects stationary or unstationary, you will be sitting and spinning. If one student walks in the class and he walks out, you will still see in a spinning vision only you can see them. Correct? So too, Aryabhatta is saying that Anulomagatarnostaha Pashyatyachalam Vilomagam Yadvat Achalani Bhani Tadvat Samapaschimagani Lankayam. He says, what is he saying? For that, let's go to a simulation. Okay. Okay. Now I am in Payani in the simulation. Let me go to Hyderabad. My latitude is Hyderabad 17 degree north. My latitude is. So I am here. East is here. Okay. North is here. And west is here. Are all of you very clearly able to see my visualization? Okay. So west is here. And now sun is going to set in some time. Correct? Okay. Let us say you owned a time machine. Okay. And in this time machine, shall we time travel? So let us say we will look at the sun now. Sun is there. What will happen to the sun? After some time, it will go ahead and set like this. Then what will happen to it? It will go underneath. Next day morning, it will rise and come like this. Correct? This is okay for all. The sun is constantly rising and setting. And why is this happening? We know very well why it is happening, because of the spin of the earth. But if the earth was spinning, not just the sun, right? Everything in my vision will spin. Be it the stars, be it the moon, be it anything. It will all spin. Everything will rise and set. In the night time, you can see slowly all the stars are rising and setting. Everything rises in the east. And if I go to west, everything is setting for me in the west. West, everything is setting. All the things are setting. Very interesting, right? But when I point to my north, what's happening? Look at the place here, right? There's a place here in north where there is one star which is not setting on. Here, this entire thing is spinning around the northern axis. Okay. For better purposes, I'll remove the atmosphere. Be it day or night, the entire celestial sphere is spinning. Why? Like we are spinning in a chair, it is all the time spinning. Like this upamana is very, very important to learn sciences. These were some strategies, techniques, beautiful techniques with which they taught astronomy. We'll enjoy learning astronomy for some time and then reflect about what pedagogical techniques they had in this Indian traditional knowledge system. You see, everything is rising and setting. In the north, some Dhruva Nakshatra is not rising and setting. Around it, everything seems to be spinning. And for me, in the east, if I see, everything is rising and setting. If I slow it down, everything is rising and setting. All the stars are rising and setting. Now it is so here. Okay. What if What if I go to, let us say, 6th, 21st of June, morning 8 o'clock, 7 o'clock. The sun is here. And in Hyderabad, okay, it will slowly go up. Okay, it will rise and slowly it will set here in the west. Okay. And it will become night. It will set here in the west. The setting, next day, the same sun will rise. But what if I change my location to somewhere in the north, closer to the North Pole? Okay. Let us observe what is happening to the sun. Sun. Okay. If I follow the sun is just spinning. It is not setting. Okay. This rising and setting, you will see, is happening only when it comes to places near the equator. The rest of the day, if you see closer to the North Pole, the sun is just spinning like this. In fact, even in countries like Britain, the sun never comes to the zenith. If you go above the Tropic of Cancer and below the Tropic of Capricorn, sun will never come to our Uchi, to our zenith, it will never come. These are all very interesting things Aryabhatta is saying. Okay. These kinds of facets. Oh, I think this recording was not happening. Huh?
Recording in progress.
But anyways, it will be in the live, in the YouTube live. Shouldn't be a problem. You see, this sun, keeps going around like this. Right? This is one facet. This Aryabhatta is saying, staying here in Pataliputra, he's talking about all these facets. Now, you all said the sun is rising in the east. That also can be challenged, correct? Let's go back to Hyderabad. Sun is rising and setting, let us say. I'll pause the time. I'll go to today. In our date and time mission, I'll go to today. But I'll go to today morning 5 or 6:30. Okay. 6:30, let us say. I'm going to. And slowly, if I run the time, sun is coming now. And it is coming when? What is the time? Time is around, okay. Around 6:55, the sun is rising, right? And it is coming. But is it rising in the east? Not really. It's not rising in the east, right? The sun is not really rising in the east. If I now shift every day, now the date is 28th one, same 7:15 a.m. Okay. I'll pick the same 7:15 a.m. and I'm looking at sun. Same place, same time, I'm looking at sun. Same time, same place. Okay. In Hyderabad, I picked one place. I'm going to every day look at sun at the same place, same time. If I keep jumping dates, what's happening? Every day, you see, on the 17th of February, sun is here. On the 17th of January, sun was here. 17th of February, sun jumps here. And daily, it keeps moving. In 20th of April, sun is there at 7:15 a.m. And it goes all the way and then it returns back. What is this called in our tradition? You all know this very well. This northern run of the sun and the southern run of the sun.
It's called Uttarayana and Dakshinayana.
We have the Uttarayana and
Dakshinayana.
yes. Gomati ji was saying that this is Uttarayana and Dakshinayana, which means there are certain equinoctial days, right, where the sun seems to be rising in perfect east. Till then, it was not rising in perfect east and it is dancing across. See, on this March, 21, right, this sun is rising here and then it is going up like this in this direction. Then when you come to September 21, right, again if you see, right, sun is rising in perfect east. September 22, rising in perfect east. Right. So these are equinoctial days. All these Uttarayana, Dakshinayana, the time when it will start, what will happen, all these are well documented in the Indian tradition. Very careful observation of the sky. And that is why you need a trigonometry, right? You draw an arc length, you draw a chord to this. The length of this chord will tell you what angle it is, correct? See, how will you measure angles? You remember in trigonometry, I showed you chords that will show the angle. So knowing the length of the chord, you can know the arc length. That is called sine inverse function today. This is called Chapakarma in the Indian tradition. So you will keep a triangular, observatory and beautifully draw this. Okay. So now I hope it is clear. Be it sunrise, sunset, moonrise, moonset, starrise, starset, everything happens for particular latitudes. In other latitudes, it doesn't happen like that. That is why he says that Anuloma gatir naustaha pashyatyachalam vilomagam yadvat. He's saying that. So if I'm sitting on a boat, and if I were traveling on this boat, when I go forward, things seem to be coming back, right? Anuloma gatir naustaha pashyati achalam vilomagam yadvat. So too, achalani bhani tatvat. So too, the unmoving stars, seemingly they rise and set. And they have a uniform motion, westward motion, uniform motion. One day they are not fast, one day they are not slow. A uniform motion. Samapaschima Gani Lankayam. For someone on, so Lanka does not mean Sri Lanka, it means a point on the equator. Lanka is a point on the equator. When you are on the equator, everything will perfectly rise and set in the, it will go perfectly in the same arc. In Hyderabad, we saw sun was, rising east and going slightly slantwards. Okay, but if you are on equator, it will perfectly go up and then set down like this. Without going to equator, he's saying this, right? Amazing. So these kinds of mathematical prowess, astronomical prowess we had, observatories we had built, Jantar Mantar, and simple, beautiful observatories we have had. These are all some among the powers, the Indian tradition. Udayastamaya nimittam nityam pravahena vayuna kshiptaha. Okay. All this we have had. He's saying that this happens, and this propelling, like the framework of reference. So we know now how to see the rotations effect, right? Earth has two motions. What is the other motion? What is the other motion that the Earth has?
Revolution.
Revolution, right? So this revolution, how will we know the revolution now? How can we observe the sky and see there is a revolutionary motion for Earth? It is tough to say that. But it will look like other celestial objects are revolving. You would have heard the word graha, right? You would have heard the word graha. Graha means planet, they would have translated. But bad translation. Graha means grinhati gati visheshan iti graha. What is that? We will see now shortly. But before that, let me show you something else. Okay. Can you all see this? So now the Earth, if you carefully see the Earth has a tilt. It is not perfectly 90 degrees with respect to its orbital. its orbital is like this, but we are tilted in this orbit around the sun, correct? So we have a tilt, and this tilt causes all our. So if we go around like this, right, throughout the year, if we go around, there will be some time when this tilt does not matter. The tilt certainly does not matter. How much light the northern and the southern hemisphere receive. They will receive equal amount of light. Then if you continue, there will be a time when the northern tilt is more closer to the sun and the southern tilt is not so close to the sun. And that's why we see this Uttarayana, Dakshinana. So for an observer here in the latitude, he will see the sun to be rising to his north of east. Right? All these today I have to explain with an animation, but people wrote it in verses. They wrote this in songs. They taught this very carefully to children earlier. These kind of sound sciences were part of our educational model. Quite brilliant and amazing. Okay. Now, another question. Very, very wonderful question. And very, wonderful thinking on part of the Indian astronomers. Okay. So how will I know I have finished 1 year going around the sun? How will I know I have come back to the same place? One revolution around the sun is called 1 year, correct? So if I revolve around the sun, I have come back to the same place. How will I know that? Any guesses?
Climatic changes.
Sorry, ma'am. Good guess. What were you saying? Could not hear. What were you saying, ma'am? Okay. See, how will we know we have come back to the same place? This is
We
a very.
have the tithis and the months and all, right? The minute you finish that Falguna, Bahula Amavasya and come to Chaitra Shuddha Padyami, you know that the earth has completed one revolution and has come to that particular time, right?
That is how the calendar would say, but why?
Mm.
Good answer, ma'am. That's how calendar say. So the principle is this: how was the calendar designed? Is the question. The calendar is designed by Indian astronomers, right? How has it?
Yes.
How has it been designed? Is that, see, if I want a circular motion, if you make one child go around in a classroom, you make one person stand in the center. And if the child goes around in the classroom, I must know how he has come back to the same place, how he will know. He will look at the floor and he will check if he has come back to the same place. In a circular
Exactly.
orbit, I will not know if I come back to the same place and have completed 1 year. Hence, I should see the background of the sun. So if I was here, I will see a different background. If I was here, I will see a different background behind the sun. Now, if I was here, I will see a different background. Correct? Behind the sun, what is there? It will change. And if I come back to the same place, now I know the original earlier background, what was here has come. So that is how we started looking at the Rashi chakras. So how do we do that? For that, let's go to one more simulation. For that, we should know the background. Okay. So what I'm going to do is, for the purpose of this, simulation, what I will do is, I will remove the atmosphere. Okay. And we will see. If there is atmosphere, it will be tough to see what is in the background, because in the background, there are many stars. Okay. If I come to today and come to morning, 5 a.m. Okay, let's go to 7. Sun has risen up. And which Rashi is Sun in right now? The background of the Sun is seemingly in the Makara Rashi. Correct?
Yeah.
If I remove the atmosphere, you will be able to see the Sun is in the Makara constellation. The background of the Sun I'm seeing right now. The background of the Sun I'm going to see right now. Now, if I go in time, if I jump dates, today 27th, Sun is here. If I keep jumping, Okay, if I keep jumping, see, around mid-February, around mid-Jan, sun entered Makara. So we celebrated Makara Sankranti. Then it exits around the mid-February. Do you see 14th of February? It has exited Capricorn and it is entering Aquarius or the Kumbha Rashi. So this is how the Rashi Chakra system came to be. The Rashi Chakra is the path that the sun apparently goes through in a year. For an observer, it will look like the background of the sun is changing. Okay. It will look like the background is changing. Now it has come into Meena Rashi or Pisces. Then from there, it will go to Mesha. It is during Mesha, when it's in Mesha that we'll celebrate various New Years, be it the lunar calendar or be it in solar calendar. Close to that time where the moon is, lunar calendar will dictate that. In the Amanta system, where your new year month and will start with a new moon, you will celebrate then. Like that in a Sauramana system, in the sun-based system, you look for the sun's position and celebrate. So this, for example, now Rishabha Rashi, right? So now the Prayagraj, how will you determine you want to celebrate an event in Prayagraj Mahakumbh? Now the Jupiter must come to Rishabha Rashi and the sun must be in the Makara Rashi. Then only you will celebrate this particular event. When you look at, I'm sorry, Shailajaji, you are annotating. I think I should remove the permission to annotate. Kindly do not annotate. I'm not able to quickly remove the permission. So this kind of aspect, right? Throughout the sun. See, if I enable the background, all this, how will we see? For me, every day the sun is moving here, there, correct? That is how it looks like. In that position, it is rising. But we carefully observe the background of the sun when you can't even see behind it. By carefully understanding when the Purnima Tithi is happening, 180 degrees away would be the sun. Knowing some among these facets, knowing the moon, we determine the position of the sun based on the reflection of the light from the moon. And we carefully calculated many of these things. Unbelievable, ingenious Indian astronomers. Then it goes into the Karka Rashi. So that's why, from the Kataka Rashi time on, there is Dakshinayana. Then comes Simha. Nowadays, from Mithuna itself, the Dakshinayana starts. Then comes Kanya, Virgo. Then comes Tula. Then the sun seemingly enters Tula. Then Vrishchika. Then Dhanu. Then again we are back to Makara. That exactly 1 year we have now completed. We have come to 27. Same 27th of the next year, 2026. Then it will come back to the same background position. So like this, we designed an astronomical system. That way, when you are born, what are they trying to do? They are trying to do the geospatial timestamp. They are trying to give a timestamp. Where are the different planets? What is the background of the different grahas? And why are they calling them grahas? Grinhati gati visheshan iti graha. It takes a vishesha gati, vishesha motion. All other celestial objects will rise and set. But these alone, these moving objects alone, they will have a background. In the background, it will keep changing of those stars. All this they have studied carefully in the Indian tradition. And hence they created a framework of reference. Okay. And using this framework of reference, they said that if I go around, what background do I see around in the celestial sphere? How do I determine? Right? And this tilt, or they understood, Indian astronomers measured this tilt to be 24 degrees. Today it's 23.5. In fact, it oscillates from 22.5 degrees to 24 degrees. It keeps oscillating. So these are some among the facets that Indian astronomers have taught. And these, like in math, astronomy, we had some time to at least get a glimpse of how complex our math has been, how advanced our math has been, how amazing our even foundational education in math has been. how amazing it has been, in astronomy. Similarly, in chemistry, metallurgy, if you take different fields, Indian knowledge systems has played a foundational role in the society. It not only advances the civilization's collective knowledge, but also by kindling the wisdom to lead lives towards the fulfillment of Purusharthas. You would have already seen the Purushartha framework. So Indian knowledge systems is designed such that you can certainly incorporate many of this into your life, your calendar, your vrata, everything you are doing it on, particular period. You are waiting for that particular period. If you want to celebrate Ramanavami, it must be the Shukla Tithi. What is Tithi? Tithi is 12-degree movement of moon with respect to sun. Okay, 12-degree movement of moon with respect to the sun. That is considered a Tithi. Okay. These are all superb facets that we have had in the Indian tradition. I'll show you an animation for Tithi also, so that you can better understand. See, every day, what happens in a Tithi? Every day, now let us say this is the Shashti Tithi, day 6, lunar day 6. Sun is here, moon is here. Carefully observe the moon. After one day, everything is rising and setting, that we have established. Anuloma gatirnaustaha pashyatyachalam vilomagam yadvat achalani bhani tatvat samapashchimagani lankayam. Aryabhata has told, we have appreciated that. After a day, you see the angular separation between sun and moon is increasing for the observer. Now it is becoming wider angle. Now this angle is still wider with every day. Now it's even more wider. Same 2 p.m. Same place, same sky. Okay, now you can't even see the moon. So you have to go. Right? Every day, 6 p.m. Further away. And then finally Purnima comes. Why is that happening? See, it's happening like this. Correct? It's happening like this. The sun is here. And this is what we see. This is the outer space view. This is the what we see in the sky. Out of what we see in the sky, through Anumana, through inference, careful inference, you have to model the Panchanga. Very tough. Exceptional mathematical precision. Too good a knowledge system. We are missing out right now in the education. You see, every day, if I rotate, the moon has moved a little bit in its orbit. Next day, the moon has moved a little bit in the orbit. Moon moves little more in the orbit. But for someone who's standing on Earth, he will see sun here and then moon there. Right? Next day, moves. Next day, it moves further. And then goes all the way. Every day, it keeps, for me, day and night goes. But for the moon, it keeps revolving around the Earth. And in about some, 1500 days, it's exactly opposite to. So while I am spinning, if I'm spinning, the sun will set, the moon will rise. The next day, if I spin, sun will rise and set, the moon will then rise. So like this Tithi means 12-degree angular separation, multiples of 12-degree angular separation between moon. And Prathama means 0 to 12 degrees. Dvitiya means 12 to 24 degrees if the angular separation between sun and moon is. You see our calendars, they will tell which moment that Tithi is changing. These are very, very ingenious, knowledge systems that we have had. And this is how we have been carefully, presenting many of these aspects. And this has impacted our lives also. As I said, in Bharat, it is dharma sapeksha vijnana. Whatever dharma you're following, along with it, vijnana was there. It was not dharma nirapeksha vijnana. It was no science versus Idu was not there. So it was interconnected into our lives. And the very pursuit of IKS, it led to advancing the civilization's collective knowledge. And it kindled to lead lives towards attaining fulfillment through Purusharthas. Similarly, there is plenty to draw from rich wisdom of India's way of life and knowledge traditions to inspire a global movement in education. We can blend Indian philosophies at the heart of the framework that inform principles of education. 2, we can bring out unique pedagogical approaches, like some of the things that we saw today. and bring about wholesome and context appropriate development. Today, we don't even teach children to view the sky, how to view it, how to view the moon, what is it telling about the angular difference. If you see the moon's face in itself, the kala, amsha kala itself, you'll be able to say what is the angle between the sun and moon. Similarly, content that is representative of Indian ethos, mindset, practices, and our rich scientific and cultural heritage. To end it all, Sir C.V. Raman, he observes in 1969, we have, I think, developed an inferiority complex. I think what is needed in India today is the destruction of the defeatist spirit. We need a spirit of victory, a spirit that will carry us to our rightful place under the sun, a spirit which will recognize that we, as inheritors of a proud civilization, are entitled to a rightful place on the planet. If that indomitable spirit were to arise, nothing can hold us back from achieving our rightful destiny. For that, we need, as educators, to teach our scientific heritage, not just history alone, which is also very important. And scientific heritage, what kind of heritage we come from, is very important to teach. That's why you would see that anadi.org/IKS books, we have put a lot of books for educators. Now, with IIT Madras, collaborating with IIT Madras, IKS division of the ministry, this weekend we have launched 40 sets of free videos. All this Tithi, everything is carefully explained. Please go to anadi.org/IKS primer, you will see. Similarly, go to this website and look at these books, which are all very useful as an educator for you. I'm sure it will be plenty of wisdom that you can do very well. Very thankful for all of you to patiently listening on a sunny afternoon. I'm sure after all things, you're all very considerate. You have all committed to this training in Indian knowledge system. I'm very thankful for all your passion. More passionate teachers have to absorb many of these and take it forward to our learning communities. Thank you all. Dhanyavadaha. Namaste. We can open up to any questions. Thank you. Namaste ji. Thank you.
Oh, namaste, sir. This is Gomti, and this is not a question or query, but this is just a observation that when once you go to, you were mentioning about Jantar Mantar in Jaipur, right? So if you can spend one full day, observing the angles, the movements, and then how the yogam, karanam, and all that has been calculated using the protractor and all. Your discussion, all that you have explained today would make sense, because I had the visual of that in front of my eyes. I was actually visualizing. And the minute you were talking about 12 degrees and movement and go back and come front, all those things, I was actually having that in front of my mind. So that is very nice, sir.
Yes. No, you're absolutely right, ma'am. Be it Jantar Mantar, and in fact, Jantar Mantar is nothing but a stick. If you see one among
Yes.
our books, in anadi.org/IKSED or IKS books, there is a book in which there's an activity. All you need to use is a pencil, sharp pencil and a line. And you can observe shadows and do all the calculations that you want to do. It is there available. You can see some among these facets. Very nice
Yes.
pedagogical techniques are there. In an introductory class, only some content was able to, but you are
Yes.
right. I mean, we have very nuanced civilization, very scientific temperament. We have had pursuits of science in multi-dimensional ways. All this, as educators, we should bring to our children. Do more educational research on many of these dimensions. Bring all this to our children.
And also the Konark temple, where you just mentioned, right, the line, the pencil and the shadow. That would be clearly depicted, where you put one thread you put one, what do you call, the broomsticks needle in that, and then you keep rotating it, and then you find the shadow and you calculate the time. Yeah.
Yes, yes.
Beautiful, sir. Your lecture was very good.
Thank you.
Thank you so much.
Thank you.
Thank you.
Yeah, thank you so much, madam, and thank you, Acharya ji. Really, it is a wonderful session. All the participants, really, they become the Chaitanyam with your wonderful that Acharya Chaitanya ji's words and also the preachings and teachings through this wonderful session on that here science and technology and Vedic mathematics and astrology. Really, Guruji, all the participants across this colleges of Telangana, teacher education colleges, including students also, that every participants they feel there in that astronauts like Sunita Williams and also that Kalpana Chawla, like they visualized like we are showing and all that sun setting and sun rising and all these things. So through this they got inspiration to study and also look into that research on these areas and so with this on behalf of the Department of Education, Osmania University, and the organizers, and on behalf of all the participants and also the teacher education colleges of jurisdiction under Osmania University, we express our wholehearted thanks to you and namaskar to you, and thank you very much, Guruji. And we will expect the same academic journey with you in the very near future also, and we will receive your wonderful inputs among our scholars and recently one of our scholars has done on this Indian Gurukula system maybe he will approach you and to learn many things and receive from your inputs, Guruji. Thank you so much. Pranam. Pranam. Thank you, Madam Ji. Over to you.
I think the feedback form has come only as a message to me. If Kishore sir can post it for all, it has come as a direct message. I think. Now it has come. Yes, yes.
Yeah, already it's posted. Already it's posted. Second time again I'm posting.
Sorry.
Yeah, Guruji, our participants are requesting to know your mail ID to contact with you.
Sure, sure. MAIL mail at anadi.org. I'm accessible through that, G. I'm posting.
It's my kind request to all the participants, just go through the Anadi Foundation website. You will see the lot of things. Specifically, yesterday only they launched a 40 video library for the sake of children. It's a wonderful contribution by the Anadi Foundation. You please go through that. I think that will be very much useful for your students. You can transact and you can use it that to create a effective and simplify the classroom situation. You please go through that Anadi Foundation website and you feel so happy. And I need to express special thanks to our Brataji. Really, there is no words at all. There is no words at all. It's a heartful thanks to Anadi Foundation. And special thanks to our department, our authorities. Really, they given a nice opportunity to listen all these things. Thank you very much.
Thank you, G. Namaste, namaste, namaste. Thanks a lot. I'll end the live stream here for all, G.
Yeah. I request all the participants kindly motivate more teacher educators to participate because we have more 2 days only. And coming day, there is a very big activities going. You will see that on second day. That means last day. You please use it. Madam will announce very soon. Thank you.
Recording stopped.